Hello everyone, thanks for coming in. My name is Gonzalo Cordero, and I'm here today to share with you some of the things I've learned while I was working on the Yahoo local mobile app. So, cool. The agenda for the talk is going to be, I'm going to show you a quick demo of how the app looks like, and then we're going to go into the moving pieces of the app and just trying to dissect it into and explain what's going on behind the scenes. So let me just show you a demo really quick of what the app looks like and what it does. Okay. Let me move this out of the way. Cool.
You can move that to the other screen.
Okay. Awesome. All right, so this is the app. Basically, what this does, it shows you things that are going around your area. So in this case, news, things to do, deals, events, and it just lets you browse around them. And so let's just navigate around. Now, while I demo the app, I want you to start thinking in your head about which parts you think are driven by web technologies and which ones do you think might be native. And then we'll go after and discuss those. So the first thing you might notice is a little widget here, weather widget here, where we can just navigate around, see, oops, things around Sunnyvale. Let's just get here to this little widget up here, down here, where some of the movies are playing or were playing on the movie theaters. We can just do this and nicely navigate through all of them. We can also do things like we go into detail, detail view of one of the movies. We get to present it with this view where we can just go around with a flicking behavior like that, back and forth, and that will be changing the details of the page. We can also refresh the data if we want to, doing something like that. Pull down to refresh. I'm sure you've seen it before. But yeah, basically that's the app. And yeah, what I want to do is just show you guys some of the things that are going on behind all of that. So let me go back to my presentation real quick. All right, so one of the first decisions that we needed to face when we're designing this app was trying to decide which parts we wanted to be native and which parts we wanted to be web, right? And again, this isn't like a exact science, and each case might be different for depending on what you're trying to build. But we kind of came up to the conclusion that we wanted to use native for anything that needed to tap into the hardware's API. So anything that needed to access the device, we needed to use native for that. Obviously, we also wanted to use native just so we could put it on the App Store. So yeah, that's a big one, I guess. And that's it. Really, that's what will we use native for. Now, there's a few gotchas that I'm gonna be covering later on, but overall, that's kind of still applies to when you're trying to think about designing your mobile web application or your hybrid application. This is when you might want to be using native, and then web for everything else. And why? Because you already know how to do it. Not only that, but you're probably really good at that too. You're web developers, and you live and breathe those technologies, and so should be easy for you to be able to create really good applications just using HTML5, CSS, and JavaScript, YUI. You can also, again, just write it once, use it everywhere, so Android, iOS, Windows Phone, anywhere. And this is a big one too that PMs love. Being able to update your code and push updates whenever you want to, without having to submit an update to the App Store and wait for the approval process and whatnot. So it became clear to us that it seems that what we wanted to create was something that combined both of them to create this hybrid application. And you know, again, you know, native, we use it, and we ended up using more than we wanted to. So why? Well, maybe it was the beginner's price of not knowing really, you know, what we could do and what we could achieve with web technologies. Some of the web technologies, one of the features that we wanted to use weren't reliable, and some of them were actually not there. So what we use native for is anything that has to do with geolocation, anything that means navigating through the app. So all those navigation bars that you saw on the top and the bottom of the app, those are native. And then storage. Now you might be thinking why, we'll go into the web, but first, but we use the web for everything else. So all the content and all the interactions. So remember that pull down to refresh event that I showed widget? That's done using web, YUI. That's little carousel over there, just a scroll view widget. And then that the core flow detail page that we saw, that's just using that flick event from YUI and CSS3. So this app is using Objective-C, HTML5, CSS3, and the last piece was actually the easiest part to figure out and to make a decision on, which is YUI. So I wanna take a little break here and a little pause just to make a little remark on YUI's approach to mobile. So I think it's really remarkable that how YUI is not diverging or branching off into two separate paths, creating one path for mobile and one path for whatever we had before. Instead, we're just creating one single library that covers everything. Because really, there's no such thing as mobile web. There's just the web. There's nothing. There's no TV web. There's no phone web, mobile web. Just the web. And so you shouldn't be writing your code depending on what you're trying to deploy to. Your code should just be working across all your devices. So just kind of like an analogy, when you're thinking about when you were doing things like subscribing to an event, using YUI or any other library, and you didn't have to worry about which browser you were trying to deploy to because you knew your library was going to just take care of all that for you. So the same way applies here. If you're subscribing to a flick event, for example, you don't need to worry about where that code is going to run into. You know that if you have a flick event, that you're going to be able to just do this with your finger if you're on a phone, or with your mouse if you're on a PC. So that's kind of like the takeaway kind of approach from YUI with all these new devices that we're seeing. So I just wanted to really make a remark, again, we're using it, and see this is some of the components that we use in the application. So we use loader to load all the assets and JavaScript files and data. We use events for anything that has to do with interactions. And we use substitute to do our templating, just a string-based replacement. Now, if I had to do this today, if I had to redo this application today, I would have used transitions on the app framework. But unfortunately, the app framework wasn't ready at the time we were working on this. So that's one of the biggest reasons why we needed to create the full navigation using native components. So with that out of the way, let's go into actual dissecting the app and see how it's done. So the first thing we need to do is delivering the app. So this is done through the App Store, like I mentioned before. We put this on the App Store, and that's how people can start downloading. next question that came into our minds was, okay, what do we put in there? So we ended up putting all the basic files, all the core files, including YUI, and also everything that we knew wasn't going to change frequently. So images, CSS assets, things like that we knew it was going to persist for a while. And then the rest of the pieces, we'll just be loading them on demand as we need them. And obviously, we use the loader for this. So for those of you who don't know what the loader does, the loader will bring you what you need depending on what you're trying to deploy to. It will know all the dependencies too for you, so you don't need to worry about any of that. And it will bring it just when you need them, just when you ask for them, which is pretty cool and pretty powerful, especially when you're thinking about mobile devices and you're worried about space and HTTP requests. You don't want to really overload your app and bring in too much stuff that you might not need. So just bring it when you need it. And then you can use the loader manually or automatically. We ended up using manually because we knew that our application was all you needed to run on the iPhone. But if you're running something that needs to run everywhere, desktops, mobile, TVs, everywhere, you can just specify the generic name of the package. So let's say I need Node. So you can just say, just give me Node, and then the loader will figure out which device you're trying to deploy to, and then it will just give you the specific that you need for that device. So that's pretty cool, right? I mean, that's pretty powerful, not having to worry about all the dependencies and what you're trying to deploy to. Just try it once, and you're good to go. Pretty cool stuff. And then once you have all of this downloaded, all the different pieces, you definitely want to cache it, because when you're thinking about performance, especially on mobile devices, caching is one of the biggest ones, so you can reduce HTTP requests. And again, we're using native for anything, like I mentioned before, that has to do with storing, and then we'll go into detail on that. So you might be thinking or wondering, why do you use HTML5 manifest for caching all your data? We could, but at the time, we saw some inconsistencies. The first one that we saw was that if we were to turn off the phone and then turn it back on, all of our data will be gone. So that was kind of like a big issue right there. And I haven't tried this in iOS 5. This was at the time of iOS 4. So that might have been fixed, but that's one of the big ones. The other one was that actually when we wanted to flush the cache, it wasn't that easy. And we had to go through many interactions until we are actually able to flush it. So that's one of the reasons why we actually just ended up using native storage. The other side of this is caching the data. So in this view, for example, that we're on the all items view that you saw earlier, we might want to load another similar view over there, which is things to do. And the only difference between the two is just the data, but the layout and everything is just the same. So in this case, all we're doing is, in memory, we're keeping this template object and then bringing JSON data and then using substitute to just parse it and just create the new view. Just a note on this: if you're doing very simple templating and parsing, I think it's okay to do this. But if your templating are complex, you probably want to do all of that on the server and then just bring everything constructed, even the markup. Just a side note. The next one we're going to go and talk about is navigating. So how do we move around the app? How do we do things like this? How do we go from one point onto the other? So again, all the navigation is done via using native. And the reasons was some of the things that we wanted to use was, weren't there. And there were a couple of things. First, position fixed wasn't working on iOS 4. That little thing up there needed to stay always on top, and that wasn't working. So that's one. And then the other one was that to create something like this, where being able to create a navigation control system where you will remember where it was and the previous and next and whatnot. Well, the app framework wasn't there, so you know, because of business pressures, we didn't have to tie into roll our own, so we decided just to go with native. However, this didn't come cheap. And so let me explain to you what happens. This is the detail view right here. Now, we want to be able to click next and previous and go to the next view and to the next one, previous view. Because all the content is coming from the web, there's already a disconnect between the native part, the native layer, and the web layer. And so we needed to load the whole thing first, and also bringing information about the next and previous document, just so we can pass it to the native, so the native layer will know what to do when someone clicked previous and next. So load the view, block everything so the user wouldn't really interact with anything and mess the page, enable that once I was loaded, and then send the article back and forth. So as you can see, there's major drawbacks with this. First, we have more data than we needed. Now, not only we needed to load the whole thing, the whole view, but now we need to load information from the previous and next document. We also ran into different race conditions. You know, it's like when the native view needed to tell the web view I was ready, you know, it was ready, and so on. So we need to block everything until both were on the same page. And again, this also ended up in several bridge calls, which comes with a price. And we'll talk later about the bridge and what that means. So again, if I had to do it again today, this solution would have been much better, much easier, and cleaner, and probably faster. So instead of having all that nonsense, I could have just have the app framework, have a route that would just load all these guys, and that this guy would have all the information needed in one place. Same with transitions. I could have just done something like this. That much code could have given me something like this, going from one place into another. Just JavaScript, that easy. YUI. So again, doing all the navigation and all the transitions with web means having one technology stack, being able to deploy everywhere, and not having to worry yet about one more thing that you need to create for Android or Windows or wherever you're trying to deploy to. All right, so the next part is gestures. So now we have the application loaded, and now we have we know how to move around. So now we want to be able to do things like this, like I showed earlier, right? Just being able to go with my finger or with my mouse and just go and navigate away. So how do we do it? Just that much code gives you that effect that you saw earlier. Subscribing to a Flick event, that easy. So all you need to do really is just get your container, subscribe to a Flick event, pass in some options. In this case, the minimum distance I wanted to travel to the Flick event to actually come in place, the velocity, and on the x-axis. And then, once I have the event, do something, go to the next movie or something like that. Now, again, I want to stress this point because this is very important. That Flick event would have worked the same on a PC. This is not just for a phone. Now, if I was to load my app on a browser, on a PC browser, I could have done just this with my mouse. It would have worked just the same. So you see the value behind using YUI when you're thinking about deploying your applications everywhere. Now let's say you also wanted to have a little more control over what were happening behind the scene of that flick event. So in that case, you can just use these low-level events that we're providing for you to actually have fine-tuned control of what's going on behind the scene. So just quick example, let's say I wanted to detect which direction the flick is happening, left or right, so I can populate the next movie or the previous movie. So in this case, all I need to do is subscribe to when the movie starts happening, detect it, grab it, and then once the event, the gesture is done, then detect the end point, and then that way I can know where my flicking is going, to the right or to the left. And all of this is using all the once and delegate goodness and all that sugar syntax. It's really easy. We're also using scroll view. So like I showed earlier, that little carousel over there, using YUI scroll view. Really fast, even on low power devices, like the iPhone 3G. We loaded with a bunch of movies, and it was just like no problem. And all you needed to do was to all it took to get that going was just passing in some markup. In this case, list of elements with images, and then this much JavaScript. So I'm just saying the source node, specifying the source node, my flick event, the acceleration, the bouncing, and the width of my carousel. And that's all. That's all it takes to get something like that going. All right, so next up, offline and saving mode. So when we're talking about offline, we're talking about two different cases. First, the one that we wanted to be able to load or use when the phone, we launch the app and there's no connectivity and we still want to see something on the screen. So again, for this one, we're just using, we're putting on the data that we needed on native storage, and then just Y substitute to create and generate the view. Now, for this one, I think we could have get away with just using local storage, HTML5 local storage, but we didn't. But you probably could, and that's probably reliable. So that's one part of the offline mode. The other bit is that we wanted to be able to save some items to consume later. So let's say you are on, seeing this movie information and you're interested and you wanted to take a look later, and you might not have connectivity. You might be in airplane mode or something, and so we give you this save button that kind of like the read list feature. And so at that point, we will grab all the content and save it. So we needed to cache all the core files, which hopefully we already did have cache from previously loading our view. All the content, obviously. So by that, I mean all HTML, CSS, JavaScript, and media. So videos. So we wanted to be able to save trailers, movie trailers, pictures, and things like that. And so because we needed to do that, and they're big files, again, native storage. So kind of like the conclusions for when you're thinking about saving and offline caching is, if you need something that's very big, use native. Otherwise, if you're just caching and saving data, you probably can get away with just using local storage and just using templating to generate your views. All right, so let's talk about the bridge. So the bridge is just a way to communicate, to enable bidirectional communication between the web and the native layer. So some of the examples where we use the bridge, going from native to web, would be, we have this view where we're reading articles. We needed to be able to bump or decrease the font size. And because, again, the controls were done natively, we needed to create this communication between native and web. So someone will type in there, will make the things bigger. Send an event to the WebView. The WebView will apply a new class name, and that's all it took. And so how do we do that? Well, Objective-C native gives you the ability to parse and to execute JavaScript via eval. So what this means is that you need to provide access to some global space for JavaScript for Objective-C to call into. So we just did that, putting some function on the y.env space that the native could call into. And once we graphed it, we'll have like a little switch statement depending on the action. And then we'll call with apply to the right YUI module. So it's not too complicated. So that's how you do from native to web. From web to native, there's two ways you can do it. Via XHR or window allocation. All you need to do is just navigate to a protocol that both the native layer and the web layer agree upon. So using window allocation, all you need to do is something like this. You specify a protocol, whatever that is, and you pass in a URL. The URL can be anything you want. In this case, I'm just doing something like my action parameter 1 equals to full, or blah, blah, blah. Then on the native side of things, you just need to be watching for that protocol. And if it matches, then you intercept it. You prevent default, if you want to call it, translate it to web, and then parse the request and do something. Otherwise, just keep on navigating. So that's kind of like pseudocode, how this works. You could also use XHR if you want to. However, if you're loading your content from a different domain and that content is trying to make a bridge call, you will run into cross-domain policies restrictions. So it works nice when all your content is coming from device, when you're accessing just the file system. And this is kind of cool because you can also take advantage of the whole success handler and send data back. So there's kind of a little bit of a feedback between the native and the web. It's a little bit more reliable. So with that, that's kind of like all the moving pieces, general moving pieces of the app. And so what I want to cover now is I want to share with you some of the best general practices that we learned while working on this. So first, everything you've learned through all these years, all the YUIConf that you attended, all the YUI theaters you watch, all those tech talks, everything, it still applies. And it applies more than ever. Because when you're thinking about these devices, you're thinking, yes, WebKit, now I can use WebKit and all the HTML5, and I don't need to worry about all the stuff I learned for i6 and how slow it was and blah, blah, blah. But the things you don't realize is that the WebKit on your phone is not the WebKit on your computer. The WebKit on your phone is more like your computer like 5 years ago. So keep your JavaScript small, because now you not only worry about performance and memory consumption and all of that. Now you need to worry about battery, which is something new to all of us web developers. So your JavaScript, keep it small. Don't touch it at all. That still applies. Same principle. And keep it small. And again, every byte counts a double in the mobile space, just because we're so constrained with the memory and the HTTP requests and things like that. So watch out for your JavaScript. Reduce the HTTP request. This is a big one. How do you do it? Pre-pack as much as you can. Put it on the app. Deliver it. Get rid of all the small images, backgrounds that you might have through your CSS. There is a great tool that Nicolas Sekas wrote that will go ahead and parse all your CSS, download all the images, and then convert them for you into data URI, and then put them back into your CSS. And at the end of the presentation, have a slide with all those resources So once I put it up, you can download it and take a look if you want to. And then again, just use cache templates for loading stuff that it's probably similar. Perceived performance, this is a big one. Just make sure you're always in touch with your user. Give the user constant feedback. Because you don't want your user to tap somewhere and then nothing happens and he thinks something is broken or slow and keep on tapping and tapping and that might be resulting in multiple HTTP requests or who knows. So make sure you're in constant touch with the user. Shrink your images. If you're consuming content from your desktop, make sure you shrink it down because you don't really need those big images from your phone. So again, HTTP request, very expensive. And last, take advantage of all the shiny stuff, right? So use CSS3 as much as you can and don't use images. Text shadows, box shadows, but again, watch out for those because those are also memory hungry. So if your design has a lot of shadows of any kind, rethink about it, and you probably don't need all of them because they're very memory hungry. Hardware acceleration, use it, but don't abuse it because every time you do something like that, it creates an image, and that image takes space in memory. So again, watch out for those. And lastly, just use all the HTML5 goodness, all the semantic new stuff. So almost there. But I do have one more thing I wanted to kind of ask all of you, which is, if you have something that you've been creating and you've been working on, please consider contributing to the gallery. Some of the things that you've seen today, some of the modules you've seen today, like the pull down to refresh and the carousel, we put it up on the gallery for everyone to use. So if you have something cool going on, put it into the gallery because that's the only thing we're going to make this great library even better. And so final thoughts, YUI is very well suited to create both hybrid and web applications, and there's nothing stopping you from using and creating web applications mobile web applications using YUI. So this is the resources, and that's all I have. Thank you.